Hi everyone and welcome to Dr. Jankila's lectures. Today's lecture is about arterial blood gases. So it's really important to be able to interpret acid-base status of a patient. So without further ado, let's get into it. So arterial blood gases, I'm just going to refer to this as ABG, short for arterial blood gases. And the way you're going to see ABG, basically, if you're working or if you're taking an examination or in any quiz, so the way you're going to see this is basically you're going to see, so ABG, it's going to equal pH slash PCO2 slash PO2 slash HCO3 slash O2 saturation. So let's get into these one by one. So first one, we're going to go over the pH. So pH, basically what it tells us the acidity or basicity of a solution. So acidity or basicity of a solution. And the reference number for pH is basically, or in other words, the neutral pH is basically 7.35 to 7.45. So, what does this mean? It means that if the pH is going below 7.35, so it's less than 7.35, so pH is basically decreasing. So in this case, protons concentration is increasing, and vice versa. So basically, if pH is increasing, so which means pH is larger than 7.45, this means protons concentration is decreasing. So basically the solution here, because pH is going over 7.45, so here what's happening is basically the solution here, it's becoming more basic. Okay, and here, because it's decreasing less than 7.35, the solution is becoming more acidic. So here it's going toward acidity and here it's going toward basicity, depending on how the pH is moving. And the body always tries to stay with neutral pH, balances each other out. And there are two organs in the body that contribute to the neutral pH. So the first organ is basically, so first one, it's the lung, or we can say the lungs, both of them. So in this case, for the lungs, it's related to PCO2. How is that related to PCO2? So basically the lungs, what they do, they maintain, so they maintain neutral pH by controlling carbonic acid. Carbonic acid is basically H2CO3. That's what carbonic acid is. So what the lungs do, basically they control carbonic acid, which is directly proportional to PCO2. So what does this mean? Basically, if carbonic acid increases, PCO2 increases as well. Okay, PCO2 is the partial pressure of carbon dioxide. That's what it is. And CO2, basically what it is acid. So CO2 acts as an acid and a buffer as well. So that's how the lung basically contribute to the neutral pH over here. That's how they contribute, leading to neutral pH. So the second organ, it's basically the kidneys. So what the kidneys do, and this is in relation to bicarbonate. So what the kidneys do basically, so they maintain neutral pH by controlling the absorption or elimination of bicarbonate. Which is in this case HCO3. And HCO3 act as a base, and it's also a buffer. So we can see here that we have an acid and a base, and that's how these organs basically maintain the neutral pH that is needed for the body to keep it in between 7.35 to 7.45. So what are the reference numbers for CO2 and for HCO3? So for CO2, reference number basically it's 35 to 45, and this is millimeter of mercury. And for bicarbonate, it's basically 22 to 26 milliequivalent per liter. So an easy way, you can keep this in your mind, like these numbers in your mind. The basic and easiest way is basically, first of all, let's look at the pH. We said it's 7.35 to 7.45, right? So this is the pH over here. Next we have the PCO2 or CO2, right? So we know this is 7.35 to 7.45. The way I keep it in my mind is basically I take the 7 out, okay? So where we ended up with 3.5 and then 4.5. And this is the reference number for CO2, 3.5 to 4.5. So now when this is 7.35 to 7.45, just taking the decimal place and the 7, leads me to 35 to 45, and that's exactly the reference number for PCO2. So you can remember these pretty easy just by memorizing the pH, knowing the neutral pH is between these two numbers, and then memorizing the bicarbonate, which is 22 to 26 over here. You can actually tell the whole three of them just by knowing the pH and then knowing the bicarbonate, because the CO2 is basically 35 to 45. So just knowing the pH, you can tell the PCO2 reference number. And I want you to remember this. If you're taking for an examination or if you're working in your job, you're not going to be able to pull up the reference number every single time. So this is something that you're going to keep to memory in order to be able to interpret the result really quickly and to come up with the conclusion. So now that I have interpreted this, or have better understanding with what is ABG, right? Now let's jump into interpretation. How can I interpret this in case of acid-base status for a patient? So I just said that ABG is basically pH and then move into PCO2 and then PO2, HCO3, and then O2 saturation. So from the pH, I said that I can tell if it's going acid, and in this case the pH is basically decreasing. So if the pH is decreasing, so less than 7.35, so this means we have acidosis because it's going toward the acidic part. So this is first one for pH. Second for pH, if it's going up, which means it's going higher than 7.45. And in this case, it's going to be alkalosis. So we have acidosis and alkalosis. So whenever you're looking at ABG, an exam, or if it's a quiz, or you're working in your job, the first thing that you want to look at is basically the pH. This is the very first thing. So this is number one. This is where you look at, because you want to determine if it's acidosis or alkalosis. That's the number one thing. Then what we're going to look at is basically, we're going to look at PCO2 and HCO3. And these two, the PO2 and O2 saturation, we're not going to worry about these. These two, we're not going to worry about them. So this is number 1, 2, and 3. Basically, these are the three things that we need to look at in order to interpret acid-base status for a patient. So now after we looked at pH, okay, from the number that we were given, which in this case, basically it's going to be less than 7.35 if it's low pH and higher than 7.45 if the pH is going to alkalosis. Now, one thing that I want you to keep in mind, and it's actually something that has helped me over the years to keep this information in my mind for a longer period of time, is that when I look at pH, PCO2, and HCO3, the only two of these three that has an H is the pH and HCO3. So what do I mean by that? So looking at this, there is an H over here, right? There is no H, just the letter H doesn't exist here, but it does exist over here. So why am I focusing on the letter H? The reason why, it's because if this is basically, if the pH is decreasing, we said it's going to go acidosis, right? So this is going to back to the kidneys. So this HCO3, it's basically reflecting metabolic. Okay, so number 1, if HCO3, it's going low, and the reference number was 22 to 26 milliequivalent per liter. So if it's going low, that means it's less than 22 milliequivalent per liter. This means it's going acidosis as well. And if number two, if HCO3, if bicarbonate is increasing, which means it's basically going higher than 26 milliequivalent per liter, this means it's going alkalosis. And this is the reason why I focused on the H, because it's the same pattern as the pH. So as the pH decreases, it's going acidosis. As the bicarbonate decreases, it's going acidosis as well, and vice versa. And the way it comes about is that the CO2, it's actually working the opposite way. So what I mean by that is, so CO2 is going to be respiratory in this case, since it's regulated by the lungs. So if CO2 is decreasing, which in this case going to be less than 35 millimeter of mercury, this means that it's going to be alkalosis, which is exactly the opposite of pH and bicarbonate. And I kept the same pattern over here. So here we're seeing number one is decreasing, which is the same as bicarbonate is decreasing and pH decreasing. However, what we see in pH and bicarbonate is that both of them, so bicarbonate and pH, both of them, when they're decreasing, they're going acidosis. In comparison to the CO2, it's going alkalosis. And vice versa, if CO2 is actually increasing, which is basically going higher than 45 millimeter of mercury, this means it's going acidosis. So how would I interpret this? So number one thing, when I am given an exam or a quiz, or you're just looking at a patient acid-base status, the ABG, the number one things to do is to look at the pH. So from the pH, we can tell if patient is acidosis or alkalosis. So let's take an example. If we take basically a patient has a low pH, which is less than 7.35, so I'm going to refer to this low pH. And what do we have in addition to that? We have PCO2, which is, so here it's going to be, let's say, less than 7.35. Here it's in between 35 to 45, which is the normal range. And then HCO3 is going to be basically, let's say, less than 22. So what we see in this pattern basically here, so HCO3 is low as well, is decreasing. It's less than 22, and pH is decreasing. So what do we do in this case? So first of all, we look at the pH. So looking at the pH, we know it's less than 7.35, therefore it's going to be acidosis. And here, because PCO2 or CO2 is normal, so we don't really worry about that. Bicarbonate is decreasing, therefore, because it's the same, so here we have an H, here we have an H, If this is decreasing going acidosis, therefore if this is decreasing is also going acidosis. And we know this is metabolic, so we know this is metabolic. Therefore, the answer to this example, it's going to be metabolic acidosis. So let's take another example. So let's take in this example that pH is actually increasing. So pH is increasing in this case, which is larger than 7.45. And then what we have is PCO2 is basically decreasing. So let's say it's basically less than 35. And then HCO3 is increasing. So higher than 26. So number one I said is basically we look at the pH. So what do we have over here? Because the pH is basically increasing, so it's going to be alkalosis. So this alkalosis. And after that, we look at the CO2 and HCO3. We're trying to see which of them is actually matching the pH. So here in example number one, because CO2 was actually normal, so we did not even look at that. But in example number two, CO2 is actually decreasing, which is abnormal. And then bicarbonate HCO3 is increasing, which is also abnormal, and it's larger than 26. But we know it's that pH has an H and HCO3 has an H. So if this is alkalosis, and this is also going the same direction as the pH, therefore this is also alkalosis. And this is basically determine patient acid-base status because it's going the same direction as pH. What I mean by the direction is basically this is going alkalosis, this is going alkalosis. Therefore, the CO2 in this case, because it's decreasing, it's going acidosis. So this is metabolic alkalosis. So to answer this example, because this is metabolic, it's going to be metabolic alkalosis. With some degree of compensation. The reason I say some degree of compensation is because we have the CO2 over here, it's decreasing. Remember, the body is always trying to go to this neutral pH. So the way the body reacts when it's increasing in alkalosis, which means pH is increasing, is basically through the CO2 over here. It's basically trying to lower that pH so it can go between 7.35 to 7.45 to keep it between that neutral pH. This is why I said with some degree of compensation, because in this case the lungs are compensating for that increase of pH. So let's look at other two examples to better understand how to interpret the ABG. So here example number one, I do have 1, 2, 3, 4, 5 numbers. And this is why it's really important to keep in mind the ABG, how it's listed. If you can keep in mind how ABG is listed, the order of it, like the pH, PCO2, PO2, HCO3, and then O2 saturation, it's going to be easy for you to know which number belongs to where. Because on exam or a quiz, you may only have these numbers. And if you don't remember how the ABG is listed, you're going to probably make a mistake by interpreting this incorrectly. But if you're working in a hospital, this is probably going to be given to you with all the pH and all the symbols. So it's not going to be as hard, but it's always good to keep in mind which one belongs to what. So let's go ahead and write that again. So ABG equal pH slash PCO2 slash PO2 slash HCO3 slash O2 saturation. So here we know that the pH is basically decreasing. So this is the number one things we do is we look at the pH. So number one, we want to determine is it acidosis or alkalosis. So we look at the pH. So this is the pH over here. This is the PCO2, PO2, we don't worry about this. O2 saturation, we don't worry about that either. The only three things we worry about the ABG to interpret acid-base status for a patient is the pH, PCO2, and HCO3. So here, looking at the pH, we know it's decreasing. Therefore, because it's less than, so the range, again, it's 7.35 to 7.45. And we know this is less than 7.35, therefore it's decreasing. So we know the pH is decreasing, therefore we know it's going to be acidosis. Now, let's look at PCO2 and then HCO3. So here, because we have the H, I'm going to look at the H first over here to see if it's going the same direction or not. So here we have 14, and we know the range is 22 to 26 milliequivalent per liter. This one is also decreasing, it's 14, therefore it's going the same direction as the pH. So it's also acidosis. And looking at PCO2, we know the range is basically between 35 to 45, and we have 41, so this is normal. So in this case, HCO3, because it's metabolic, therefore we have metabolic acidosis. So here we have metabolic acidosis as the answer to this example. So now let's look at example number 2. So what do we have over here? Again, step number 1, we're going to write down the ABG. So ABG equal pH, PCO2, PO2, HCO3, and then O2 saturation. Again, we don't worry about O2 saturation or PO2. These two, we don't worry about them. The only three things we look at, pH, PCO2, and HCO3. So, number one thing is the pH. What's going on with the pH? We see it's less than 7.35, therefore it's decreasing. So is it acidosis or alkalosis? From this, we know it's going to be acidosis. So, acidosis. Now, let's look at the H. I always like to look after the pH on the H, HCO3 I mean. It's because it has an H, so I can tell what direction it's going. So here I can see the pH is going, it's decreasing. So looking at this, has number 16. And we know the range is between 22 to 26. Therefore, this is going the same direction as the pH. Therefore, this is acidosis. And this is, we know it's metabolic. So the CO2, what's going on with it? It's 29, and we know the range for this one is 35 to 45 millimeter of mercury. Therefore, this is also decreasing. So what we have in this case, we have all three of them, they're decreasing. However, we know because this one doesn't have an H like these two, it's going the opposite direction. So if this is going acidosis and this is going acidosis, this is going alkalosis. So this is alkalosis. So, which of these two, even though they're going both of them down, they're both of them decreasing, which one is matching the pH? Looking at this is alkalosis. It doesn't match the pH because this is going acidosis. This is going acidosis. Therefore, it's going to be metabolic acidosis. So the answer to this question, it's going to be metabolic acidosis with some degree of compensation. So here what the lungs are trying to do, they're trying to compensate for the acidosis basically. Because as the pH is it's decreasing with the bicarbonate and pH, we have a decrease in, basically it's going acidosis. The lungs are trying to compensate, going alkalosis, in order trying to shift the pH to go to the neutral state. So going to be between 7.35 to 7.45. And this is the reason why I said with some degree of compensation. So this is it for this lecture. If you have any question or comment, please leave them in the comments below. And as always, thank you for watching.